Perhaps it has come to your attention how one can take out his phone, use an application such as Uber to order a taxi or a cab and get to commute at the convenience of his or her location. You wonder, how does the driver get to pinpoint your exact location? And how can you tell the driver's location by use of your phone? There are similar applications that use the same concept to offer a range of services such as Glovo, Jumia, Sendy, and Google Maps. And the list goes on and on. Funny how technology and the world has evolved. To help you understand the basic principles that enable these applications and many occupations such as those of a pilot and sailor or captain to exist, join me on today's lesson as we learn about longitudes and latitudes. Allow me to take this opportunity to ask you to take a little bit of your time, hit that subscribe button at the bottom of your screen. We are on our way to 1,000 subscribers, and your help will be greatly appreciated. Share this channel with your friends and relatives and even your colleagues so that you can be able to grow this community. At the same time, hit the bell button that is at the far right corner of your screen so that whenever an update is released on this platform, you are the first to get it. Also, do take a key consideration on the comments that you post on this platform, and you can leave us a comment on the comment section, and these will go in a long way in helping us understand areas where you have problems in and rate our service delivery. On today's lesson, we're going to look at the introductory part of this topic, where we're going to look at the various definitions that we have on this topic. We're going to understand what are longitudes. We're then going to understand how we measure longitudes, then look at what latitudes are, understand how we measure them, and then define what a great circle and a small circle are. So students, what are these longitudes and latitudes? If we look keenly at the presentation that we have here, this is a 3D representation of our Earth. We are in a position of seeing the various continents that we live in. We do have the continent of Africa, we do have the continent of Asia, we also do have the continent of South America and North America continents, as well as the continent of Australia. And these are the places where we live. We can also be in a position of seeing our oceans. And basically, this is a 3D representation of the Earth that we live in. On this 3D representation, it's possible now to see that there are lines that divide our Earth's surface into a grid system. There are those that are running from north to south, while there are those that are running from west to east or from east to west. Now, the lines that run from north to south are what we refer to as longitudes, or in other words, meridians, while those that run from east to west or west to east are what we refer to as latitudes. Now, if you can be able to define them, you can be able to say that these longitudes and latitudes, they are simply a system of coordinates that are used to specify any location on the Earth's surface, and they can help us find a way around the globe. And together, as we've seen, they form a grid that covers the entire globe. This is what these longitudes and latitudes are. Now, if you can put it into mathematical terms, when we talk about latitudes, what a latitude is, we refer to it as a measurement of how far north or south a location is from the equator. A latitude is a measurement of how far north or south a location is from the equator. We have introduced a new term, students, and that is the equator. I presume that from your geography knowledge that you have come across this term. Take some little time to remember from your geography classes what the equator is, or the definition of the equator. I'm pretty sure that you've gotten it right. Well, just for the sake, the equator is simply an imaginary line that circles the Earth at 0 degrees. And if we look at closely at the globe that we have here, that is our 3D representation of the Earth, the line that cuts our globe at the center, or that is at the middle, is what we refer to as our equator. It is 0 degrees. That means it's neither on the north side of the globe or the south side of the globe. And this is the imaginary line from which all the other latitudes are measured from. Degrees to the north or to the south of it. Now, having defined what a latitude is and our equator, we can now look at what longitudes are and how we define them in mathematical terms. And when we talk about what longitudes are, they are simply measurement of how east or west a location is from the prime meridian. Notice, students, that we have introduced another term, the prime meridian. From your geography lessons, can you remember what a prime meridian was? Take some little time to remember what the definition was. Aha, pretty sure that you've gotten it right. Now, when we define a prime meridian in mathematical terms, it's simply an imaginary line that runs from the North Pole to the South Pole and it passes through the Royal Observatory in Greenwich, England. So that is what a prime meridian is, and does have a similar role to what the equator plays. It is the centermost meridian from which all the other meridians are measured from. Now, as we highlighted earlier, longitudes and latitudes do form a grid system that cuts our Earth's surface into different portions. If we kindly look at latitudes, they do cut our Earth's surface in designated points. Let us look at the examples that we have here. We do have latitude A, latitude B, and latitude C. Latitude B is our equator, whereas latitude A and latitude C are latitudes that lie on the north and south poles, respectively. Now, these latitudes, they do cut our Earth's surface into different portions. Let us look at the globe that we have here, which is a 3D representation of the Earth's surface. Now, if we take a pair of scissors and cut along latitude A, we're going to realize that the Earth is going to be cut into two different portions. You realize that the bottom portion is larger than the top portion. What does that tell us? It tells us that once this latitude is cut, it forms what we refer to as a plane. And this plane, it resembles a circle. It is circular in nature. Now, if we then take our pair of scissors once again and then cut it at the equator, that is at point B, we're going to end up with another plane, as well as if we take our pair of scissors and cut at latitude C. We're going to end up with planes that are circular in nature. The most significant difference between these planes that are circular in nature is that we do have one that is larger than the rest, and that is the plane that is formed once you cut our globe at the equator. What does that tell us? It simply tells us that the equator is the largest of all latitudes, and the equator is the only latitude that forms what we refer to as a great circle. Realize that all the other circles that are formed at point A and at point C are small compared to the circle that is formed once we cut our globe at the equator. How about we take our pair of scissors and then cut along the longitudes that we have here? If we take our pair of scissors and cut from north to south along longitude E, we are going to realize that we are going to end up with a plane that is circular in nature, but that does not give us a solid conclusion. Notice the size of the circular plane that is formed once we cut along longitude E. Now, if we once again take our pair of scissors and cut along longitude F, what do you realize? You realize that the plane that is formed, the circular plane that is formed, is similar in size and shape with the one formed along longitude E. We can conclude that all the circles that are formed on longitudes are great circles. Students, what have we realized after cutting along longitude E and longitude F? Realize that the planes that have been generated, they are of a similar shape and size. And if we can be able to measure them alongside the circle or the plane that was formed when we had cut them along the equator, we realized that all these planes are similar and they are of the same size. We can conclude and say that all longitudes form what we refer to as great circles. Now, this brings us to the definition of what a great circle and a small circle is. We can tell now, after cutting our globe alongside the latitudes and longitudes, that a great circle is the largest of circles in the atmosphere that cuts it into two equal hemispheres. And all the other circles that are formed are small circles. But one important thing to note is that great circles are formed along all the longitudes, because all longitudes do cut our atmosphere into two equal halves, and at the equator, because it is the centermost latitude that cuts our globe into two equal halves. But at all latitudes, the circles that are formed are referred to as small circles. As we had mentioned earlier, latitudes are measured degrees north or south of the equator. It's worth noting that the maximum angle of latitude that can be measured is 90 degrees north or south of the equator. In the diagram that is presented before us, we are in a position of seeing different latitudes, that is latitude A, latitude C. Now, how do we go about measuring latitude A and latitude C? First, if we take the case of latitude A, we're going to intersect or join latitude A to the equator with this transversal line. This will enable us be in a position to measure now the angle between the transversal and the equator, or the angle between our latitude and the transversal.